Hey there, I've been wanting to make a video about a feature in C Sharp that I just think is awesome, and I don't see, I guess, enough people actually talking about it, which is this idea of an IAsync enumerable, which is not just unique to C Sharp. I guess JavaScript and TypeScript have this idea of an asynchronous iterable, and so this is very much in that same vein. But I don't see a ton of people in the .NET world talking about this. Granted, it's been around since C Sharp 8, so that kind of almost predates me learning to write C Sharp. So maybe people just take it for granted. But I wanted to highlight it in this video. And I wanted to do that through showing you guys a use case that I found to it that I think particularly highlights the benefit of having an asynchronous collection or an asynchronous enumerable like this, where you can essentially do work on demand to yield up items, but you don't necessarily have to realize the collection in memory all at once. You can just iterate over it, one at a time, and do that work, as you need it or as you want to work with those items. So let's go ahead and set the stage here. And what I'm working with is essentially a generic repository in my application here. The specifics of the application really don't matter, but essentially I have this generic repository that currently all it allows me to do is it allows me to, get a specific entity. It also allows me to get a page of entities, which is nice. So I could definitely implement my own paging logic every time I need to page over all the entities in a particular collection or a particular table, but it would be really nice if I had a method here that I could call and then do an asynchronous iteration over the returned collection and process every page of data that's actually in that collection, right? So I can work with all the items that are in the collection without having to pull them all into memory at once. I can just pull back a page of entities, work with that page, and then get the next page. And so that's what I'm going to try to implement here to kind of show you guys the benefit. And again, just to highlight again, the benefit here is I can page through all the data that's in a table or in a collection, but I don't have to pull it all into memory to do that, which is just unrealistic. You're not going to really be able to do that in most cases. So you're going to have to page your data anyways. But why not have kind of a built-in handy ergonomic way to page through it all without having to always re-implement your own pagination logic again and again and again? So that's where I think async enumerables or even async iterators in TypeScript and JavaScript really shine, is you can basically use them to sort of have pagination done for you once and then just reuse that everywhere and not have to worry about what's the right way to bring this data back and how much should I bring back at a time. Just kind of write it once and you're good to go. So I'm going to go ahead and try to implement this here without making too many mistakes. So let's go ahead and add a new method to my interface here. This is going to be called task. And instead of a task, actually, it's going to return an IAsyncEnumerable. In this case, it's going to return a page at a time of type T. And I'm just going to overload this, so I'm going to call this a get async as well. And then instead of being able to specify a page number, which really doesn't make sense because I'm just going to iterate over all the pages, I'm just going to have it specify a page size. And in this case, I'm actually going to have the page size be given last as the parameter, so I can just set a default for it. Whoops, that was from learning Go earlier today. So we'll say int page size, and we'll just set this to something like 100. The ideal default page size is it's arbitrary, it's guesswork, depending on the collection or the table of data you're talking to and how many fields are on your entities. 100 might be too few, it might be too many, but we have the ability to change that page size when we need to. Now what we'll do is let's go ahead and go to my base repository, which in this case is a Mongo repository because this application is using Mongo currently to persist data. So let's go ahead and go to that Mongo repository, and that's going to complain because we don't have it implemented yet. So let's go ahead and implement it, and we'll make this a public method. We'll make it virtual so that any deriving classes can override this if they need to in some way. So we'll call this, again, it's going to be an IAsyncEnumerable, and this is going to be a page T, and Copilot's trying to help me here. And it looks like it got pretty close. The only thing I want to do is I just don't want to implement this quite yet. So I'm going to go ahead and delete this and I'm going to throw a not implemented exception like that. And what's this complaining about? Oh, there's no asynchronous call, so we can remove that for now, which is fine. Okay, now what I want to do is I want to go actually add a test for this. So let's go to the test class, and we'll just use, I don't actually use this Mongo repository concretely because it is an abstract class. So we'll just open up my test, and we'll just go to the user repository. And that's an integration test because I'm using test containers in this application to actually test against an actual instance of MongoDB. So let's come down here in my tests, and we're going to write a new one that's just going to be called, let's say, fact. And let's just not make things too complicated with naming. Let's just say async task, and we'll say get async, and I'll just call it paginated. Paginated. I think that's how you say it. I don't even know if that's a word. It's a word right now. And then the thing I want to be able to do here, right, is I want to be able to basically create some users. So let's say var user 1, and we'll say var user 2, and let me give us some room here so this isn't so low. And let's go ahead and insert those. So we'll say await context insert mini, and we can turn this into a collection expression. And then, so what I want this method to allow us to do then is to be able to specify a filter. So we'll just say, for now, we'll get all of these. Filter specification for user, and this will just be all. And then we'll say var sort, and we'll just do it, let's say ascending, let's say sort by u, and we'll just sort by u dot created date like this. Okay, and then we'll just set our page size to 1 for testing. Okay, and then what we should be able to do is we should be able to await for each, right? So this is that construct of an asynchronous enumerable, is I can say await for each, and then I can say var page in system under test, which is, again, this is the Mongo user repository. And so we can say filter, sort, we can pass in our page size, and then we should be able to do something with our pages here. Do something with pages, right? So you can kind of already see, let me make this static so that it will stop yelling at me. So you can already kind of see, right, the power in this is that I have this very ergonomic kind of built-in native C#, right? It feels very like native to C# syntax of for eaching over this collection. I don't have to bring the collection all back into memory. I can query into the database one page at a time, bring that data back, and do some work on it. So in the case of my test here, I'm going to just create a collection of pages. I'm going to say var, let's see, retrieved pages. Yep, equals new list of page of users. And we'll say retrieved pages, add pages. And then we'll just assert down here that the retrieved pages should be 2, right? Because we have 2 users, we're setting our page size to 1, and so in order to get all of our users back, we should have to query into the database twice and retrieve 2 pages of data. So let me go ahead and just change this song because it's just not quite doing it for me. And let's go back to our code here. Sorry about that. And now what we should be able to do is we should be able to build our solution. Let's see if this builds. .NET build source data flow server. Hopefully this builds without any errors. Give that a few seconds. Nice. Okay, built. Now I'll go back over here. We'll try to run our test. this should throw an error, right? Because I haven't actually implemented the logic for doing the pagination, which is not going to be anything super sophisticated. It's going to be your basic, start at page 1, iterate until you get to the till you get past the total number of pages. You can see the test is running. These tests take a little bit longer to run because they are spinning up a database in Docker using test containers, but we should find this is going to error out. Yep, and it does, and it errors out because the method or operation is not implemented, which is what we want to see. So let's go ahead and close that. And now let's go back to our, our Mongo repository. And now let's go ahead and implement this logic. And I know everyone has their own special way of doing this. The way I like to write my pagination logic is actually with the do while loop, because the way I think about it, and let me disable Copilot because that's going to get annoying. The way I think about it is, I don't know if there's any pages of data. There might be at least one. So I always want to do the query. I want to make the request for data at least once. So I feel like a do while construct makes the most sense. Not everybody agrees, so I understand. But in this case, we'll say var initial page number equals 1. And granted, what page number you start with, 0 versus 1, is going to just kind of depend on how you're actually paging through your data. In this case, I already have all my logic for building the pages in this existing get async method that returns a single page. So I know I'm always going to just like offset it by 1. So the first page of data is going to be page number 1, and then I'll subtract 1 off of that to actually get, the 0th page. You may think it makes more sense to have 0-based pagination. I think it makes more sense for the caller to pass page number 1. It's opinion. So what I'm going to do here is start at page 1, and then I'm going to keep track of a total pages property here, or variable here. And then I'm going to do while over this. So I'm going to say do while, and my case to exit this loop is going to be when total pages is greater than or equal to initial page number. And then we are going to say var page equals await get async, which again is just calling in. This is my IAsyncEnumerable returning get async method, calling the get async method that just returns a single page. So in this case, I'm just going to pass through the the initial page number. I'm going to pass through the page size, and then I'm going to pass through the filter, and I'm going to pass through the sort. And that should get me a page back. And I need to make this method async again because now I'm awaiting. Excuse me. And then what I want to do is I want to yield return this page. And this is the part where we basically are handling that deferred, almost in a sense, deferred execution, where we're saying, hey, we just want to yield a page 1 ep at a time. Each time we iterate over this collection, we're going to give this page, and then we're going to come back into this method on the next iteration, and we're going to yield the next page. And this is all handled by the compiler, right? This is all transformed into a sort of a state machine once it gets compiled to lower level C#, and then even further down. So for us, we just get to use yield return, which makes it really nice and really ergonomic, and we can let some far smarter people figure out how to translate this into a state machine. So let's go ahead, and then after we yield the page, we want to increase our page number. So we want to say initial page number equals ++, and then we want to say total pages is going to be equal to page.total pages, like that. And you know what? I think initial page number is not a great name. I'm actually going to change this to current page number. Since we are mutating that in the loop, I'm going to call that current page number. And then we need to not forget our semicolon here. Okay, now, so what we have here basically is a way to page through all our data, get a page back at a time, We can customize the page size. We can customize how we're filtering. We can customize how we're sorting and the order we're sorting by, without a whole lot of fuss. And now when we come back to our calling code, so let's come back into our test, we just, whenever we want to actually page through all the data in a collection or in a table, we can simply just create a for loop like this, retrieve a page at a time, do whatever we want with that page, and then move to the next one. So let's go ahead and run our test. And I'm hoping I didn't make myself a liar, and this should run successfully now. So wait, give this a couple seconds. Through the magic of editing, this will take far shorter than what it appears here. We should get 2 pages back. There we go, and the test passed. There we go. So again, I know this is probably something a lot of people in the .NET space, a lot of people in the C# space probably already take for granted because it's been there for so long, but I don't see a lot of people implementing it or using it for these purposes, right? I think paging through a collection of data in your database is a great use case. A lot of APIs nowadays return data in a paginated way, so it would make sense to just have a method on your HTTP client or on your, your client that you build that wraps the HTTP client to actually call that API, to build a method that just allows people to iterate over a collection, and that method underlying takes care of making the call, getting the page back, yielding the page up, increasing the page number, and allowing the user, all they have to do is just write a for each loop like this. So I hope you found this helpful. I hope you maybe found it enlightening. Maybe it's piqued your interest or thoughts around how you can put the IAsyncEnumerable interface to work in your own applications. And of course, if I misstated anything, or you think I can do something better, or you have thoughts and ideas, please let me know. Find me on Bluesky, leave a comment. I'm in no way an expert, so I'm always happy to learn from others. That being said, hope you enjoyed it. If you did, also find me on Bluesky, leave a comment. Otherwise, I'll see you in another live stream or another video or in a short somewhere. I hope you guys are having a great day, and I'll see you guys next time. Bye.